Ever heard of recursion or recursive functions? In this video, we'll be taking a look at recursive functions in Python, and I'll be explaining to you what is a recursive function and how it works. Recursion or recursive function is a function that calls itself multiple times until it reaches a condition that will stop it. Recursions are similar to loops. They basically repeat a certain process multiple times until it reaches a condition. This condition in the concept of recursion is called the base case. It is the only block of code that will stop the recursion. What comes after it is called the recursion case. It is where we will call our function within itself. To explain recursion, we will do some examples. Let us start with finding the factorial of a number. To do that, we will use now a simple iterative function. So I'll call it def factorial it and n. Now I'll create a simple variable, the result variable, and I'll store inside of it 1. Now I'll use a for loop, so for I in range 1 and n plus 1. Like this, we won't start with 0 and we will include the n number. Next, I will say res multiplied by equal to I and return I. Return res. Basic factorial function, so we will print factorial it. Let's say 5, we should get 120. As you can see, we got 120. Now let us do the recursive way. So def and factorial. Let me write factorial, but this time it's rec for recursive and n. We know that a recursive function should have a base case. So now let's leave this empty for now and let's go to the else. What I'll say here is return n multiplied by, and this will be the recursive call, factorial rec, and this time I'll say n minus 1. Here's an animation for you to see that will explain exactly what is happening. So as you can see, n is being decremented at each call. However, we need something to stop this recursion. So at some point, n will reach the number 0. And we know that in factorial, we can't have a 0. This is why, what will be the base case? The base case will be if n reaches 0, what will happen is I'll simply return 1. That's all I will do. So let me go ahead and print what is going on in this function. So I'll say 5, I will comment this function here, this print statement, excuse me, and I will go and run this Python file and we got 120. So our recursive function actually works. So this was the first example of a recursive function. Now let's go to the second example. I want to show you how you can reverse a string using recursion, and I want to show you something else, which is how to create a local function to reverse a string. So a local function is a function within a function. You'll see how. First, let's start with the iterative way. So def reverse string, and this will be an iterative way, so I'll write it right here, and this will be the parameter string. Now I'll create a res variable, which will be an empty string. Now for I in range, and we need to loop in reverse on the string, so I will start with the length of the string -1 and then -1 and the step -1. Now I'll say here res plus equal to string index I, and at the end we shall return res, and let us first of all test this function. So reverse string it, and I'll give it the word hello. So hello, let me launch my code. As you can see, hello was reversed. So at first I will start as 0 at index 0, and the element at index 0 is O. So what will happen is we will concatenate O with res. Then I will decrement by 3. This process will keep on continuing until it reaches -1 and the loop will stop. Okay, good, let me comment this out, and now it's time to do the recursive way. So I'll write def reverse string rec, and I'll get a string parameter right here. And let's start with the recursive way. So basically I wanted to use a local function. What I will do here is I will write def local function, and what will be the parameter of this function? Well, before we add those parameters, I want to tell you something. We know that strings are immutable. That means I cannot use bracket notation and change the element at index 0 to z, let's say. That doesn't work. Strings are immutable. What I want to do here is I want to convert this string into a list. Like this, inside my local function, I can work within that list. So what I will do here is declare a variable called list, and it will store a list version of my string. Like this, what I will do here, I will give this local function a parameter of a list, okay? And what I want also is the starting index and the ending index. So let us name it end. Okay, now we need to call this local function. So I will say return local function, and I will add here the LST. The starting index will be 0, of course, and the ending will be the length of the list minus 1. That means the last element. Okay, so now let us start by building this recursive function. So as we know, we need a base case. Let us leave it empty for now, and let us develop the recursive case. So I will say else right here, and now I want to use the swapping method to be able to swap positions of the first and last element. Let us start by creating a temporary variable that will store, let's say, LST index start. Why? You'll see. So I'll say right now LST index start equal to LST index end. So I am swapping the position of the last element into the first position. But now I need to do the same thing for the first element. So I need to put the first element at the last index. So instead of saying LST start here, I'll say LST end equal to temp, which stores the value of the first element. So temp actually stores or saves the value of LST index start. Now this is a recursive function. We need a recursive call. So what I will do here is I'll say return local function. I will pass the list. Now what will happen here is that start will change. Instead of giving start, I'll say start plus 1, and I will say now end minus 1. This process will continue until, as you can see in this animation, that start and end are equal to each other. So the base case will be the following. So what I will say here, if start is equal to end, what I want to do here is basically return the list. Now I know, we need to return a string. Now what we can do here is we can create a function outside this recursive function that will transform or cast our list into a string. So what I can do here is create a def convert to string. It takes a list, so LST. I'll create a res value here, or variable, excuse me, that will store my string. So I'll say for I in LST res plus equal to I, and right now we can return res, and this is our function that will convert our list into a string. So let us see this, and let me go down here, say print, and now I will say first of all convert to string. Then I will call the reverse string recursive function if you want, and now I'll pass it hello. So let us see if it will reverse the hello string. And as you can see, it reversed it, so our recursive function actually works. However, there's a problem. This recursive function only works if the string is an odd number. Excuse me, if the length of the string is an odd number. So basically hello has the length of 5. And in our case, if the length is an odd number, start and end at some point will be equal to each other. But let's say we give it a string of 4 letters, like bear. Let me write bear over here. We shall get an error, okay? As you can see right here. So what can we do? Let me show you this animation so we can understand even better. So at some point, start will be greater than end, as you can see in the animation. What we can do here is fix this equality sign. So instead of putting the equality sign, we can test to see if start is greater than or equal to end. Like this, no matter what string the user gives us, it will be able to handle it. So right now, instead of let us launch our program, so run, and we were able to reverse the string bear. So this is what I wanted to show you, how to use a local function to act as our recursive function. Now if we want to talk about efficiency, iteration will win, because recursion attempts to cut down complex tasks into smaller tasks and solve each one by one. And sometimes recursion may lead to an error called stack overflow. Basically, if you remember the animation I showed you, I put the operations on a stack. That's because recursion uses a stack, and with larger inputs means that the recursive function will work more. It will store inside the stack too many operations, which could lead to a stack overflow. However, recursive functions are really important because throughout your development career or journey, and they will be very important to you, especially in data structures. Now I want to know your opinion. Would you consider using recursion or iteration? Comment below. Thanks for watching. Make sure to subscribe and follow for more content. And if you're looking to learn Python object-oriented programming, make sure to click on this playlist. Otherwise, click on the video that will appear next to this playlist.